Okay, so now let's look at the square root of 2. Why don't you talk and I'll write, even though that might be slightly complicated as I'm writing through the.
So root 2.
Root 2 equals, what is the integer part and then the non-integer part?
We can't really say much about the square root of 2 except that it's greater than 1. So we have 1 plus root 2 minus 1.
There we go. So we split it into the integer part, 1, and then the non-integer part, which we couldn't write as a fraction.
So it would just be over 1.
But this is still good. So now that's our split, and now we flip 1 plus 1 over root 2 minus 1.
Yep.
Okay. So now we have this expression, which, you know, when we did it with the fractions, actually at this point we were saying things were getting simpler.
But now it's gotten more complicated.
It seems like it's gotten more complicated here. So do you have any ideas on what we could do here?
If we tried maybe to rationalize the denominator by multiplying by root 2 plus 1.
Okay.
Over root 2 plus 1.
Yeah.
By convenient form of 1. We get root 2 plus 1 on the top over the difference of squares, so 1
Yeah.
on the bottom.
So this now becomes, am I on camera there?
Yep.
1 plus 1 over, this just becomes 1 over root 2 plus 1. So now that's interesting.
How did you get from, you had 1 plus 1 over root 2. Okay, yeah, I see that.
You see it? Okay, because I didn't write the divided by 1 here. Okay, so now what can I do with this part? So I've got 1 plus
We're gonna do the
1 over, what's the integer part of root 2 plus 1?
2. So 2 plus root 2 minus 1. And then we have to make this 1 over root 2 minus 1. And then we can do the same thing, multiply it by root 2 plus 1 over root 2 plus 1.
Uh-huh. So
And
this 1 over root 2 minus 1 is going to become?
Root 2 plus 1. And then that'll, you can separate out 2 again, and clearly this will keep going forever because you'll always get that 2. So this continued fraction.
Let me shift over a little bit to make sure we're on.
This continued fraction is infinite now.
Yeah, this continued fraction is infinite, which is pretty wild.
And so we said that all rational numbers would have finite continued fractions, and so this one doesn't, and therefore it's irrational.
Therefore it's irrational. Okay, so I got 4 minutes left. I'm going to show you one last little neat thing.
Alright.